So welcome, everyone. What do you guys think about the build so far? Pretty awesome, right? Oh, man. Build is literally the favorite time of the year for me. It's seeing everything come together, what we are trying to build, when we talk to you to understand whether you like it, whether you don't, whether you're going to take it further than we've even imagined. This really makes me feel awesome. And I say that like as a technologist rather than as a Microsoft employee, because this really is my favorite time of the year. I'm not even going to say that. But let me introduce myself. I'm Vikas Bhatia, and I lead the Project Rome initiative inside the Windows Developer Platform team.
Hi, everyone. I'm Carmen Forsman, and I, too, am a program manager on the Project Rome initiative. And I'm so excited to show you all the cool stuff we have today.
So let's get started. Yesterday, Satya mentioned Bill Buxton in his keynote. I don't know if you all caught that. This is a quote by Bill Buxton. What he's trying to say here is that the quality of an experience is determined by how that experience works with the rest of the ecosystem rather than just by itself. This is a very important point because our users use our apps not in isolation. They use it with a larger ecosystem. They're trying to accomplish something, and our apps help them do that. And if you don't know Bill Buxton already, he's an industry pioneer in the field of HCI, or human-computer interactions. And I've been in 2 meetings with him, and I've been like awestruck. So you should read some of his stuff. I read this when I was in college, and it's great stuff. So we're going to keep coming back to this in this talk about user engagement. And as we were prepping for this session, people asked me, what do you want people to walk away with from the session? This is what we want you to walk away with. Project Rome will help you drive user engagement. We'll come back to this a lot during the session. So let's talk about the agenda for a second. We're going to talk about the opportunity that's in front of us. You've heard about Project Rome a lot yesterday as well as today in the keynotes. I'm going to try and break it down a bit. Project Rome at a highest level is 2 pieces, the device graph and the activity graph. I'm going to dive deep into the device graph aspects. And later in the day at 5:30, Sean Henry is going to talk about the activity graph. You shouldn't miss that. We'll have pointers to that session. And along the way, we'll have a lot of demos. And if the demo gods are with us, everything will work, right? So let's get started. Let's talk about the opportunity. She looks really happy with all the devices around her. This is the world that we are living in. We spend a lot of time looking at our devices, at our screens, a lot. Some of you are looking at your screens right now. And I'm in front of you. That's OK. It's not considered abnormal anymore, right? I've heard stories about kids going out to eat, and they take pictures of their food. And I don't know if that's a trend anymore, but devices and being in front of devices is just commonplace. And we have a lot of stats that I won't bore you with. But I have a personal anecdote that I think you all will appreciate. Earlier this year, my parents visited me from India. These are these 2 65-year-old parents, and you don't know them. I know them. Obviously, you don't have to know them. But they brought 2 devices each. And this was just mind-boggling to me. They are WhatsApp and Facebook ninjas. There isn't a joke that has not been forwarded to me. There isn't a comment that they have not made on a Facebook post. And we're joking about this, but this is the life that we live in, whether you like it or not. The other important piece that I think I would like all of us to understand is a lot of us are living in what we call this heterogeneous environment. We have a PC, and we are pairing that with an Android and iOS phone most of the times. It's just the reality of the world we're living in. There are screens everywhere. There are TVs, there are Xboxes. The other important part is the last bullet point, which is most of us are starting an activity on a device, and we pick it up on another device, and we do it on another device, and we finish it somewhere along the way. But this continuation of activities that we do is just common. You might be taking a note in OneNote while you're on the go, and then you come to your office and you do something else, or you check your email while you're in transit, and you see an email from your boss, and you're like, oh, I need to reply to that, and Andrew does that all the time. So I come back to my PC and I actually finish the task. This part about moving between devices to do your activities is very common. So back to user engagement. User engagement is scattered across all of the devices throughout the day. What does that mean? Let's talk about a typical day. A day when the hours that you're awake. This is generally the pattern most of us are in. You spend 8 to 10 hours at work, fortunately, unfortunately, depending on the way you look at it. You have a couple of hours in the morning, you're resting at home, you have a commute, depending on how you work. You have evening time. But along the way, you're constantly interacting with devices. When you wake up in the morning, even if you watch Good Morning America or Good Morning wherever you are, you have TV on, but you're still on your phone doing something else. It's a multi-device activity. It's a diversification of devices that we are basically a part of. If you're commuting to work, you're taking public transportation, you have your laptop or your phone in front of you. If you're commuting by car, you should not be checking your phones. Please do not check your phones. But you're still checking your phones, right? Like, even in the elevator, I was actually in the elevator last night trying to get down to the parking lot. This person was in the elevator with me for like 10 seconds. In that 10 seconds, he whips out his phone and he checks something. We are addicted to our screens. And back to user engagement. You spend so much time in building your apps, and you want your users to use your apps. But capturing that user engagement is hard. I read some research earlier this week, which was smartphone users spend about 85% of their time in about 5 to 6 apps. And there's obviously a lot of research around people downloading apps. They don't launch them again. User retention is really the issue here. You spend all of your time building these amazing apps, and you want users to use them. And this is where Project Rome will help you. But first, we should talk about Microsoft Graph. Microsoft Graph is just awesome. Thank you, Yena. It is a way that helps you connect you to your organization, things that you do. There are devices in there, there are events in there are activities in there. If you haven't already checked out Microsoft Graph, please do. It is, like, to me as a developer, it's really awesome, because if you've ever created a view where you've collected data from various sources, each of these sources has their own authentication, authorization protocol. Each of them have a different data type that they return back, right? But what Microsoft does is, for all of this amazing data that we have one unified common endpoint, graph.microsoft.com, right? And there's one standard way to authenticate or authorize your users. And once you have them there, you have access to all this treasure store of data, which is awesome. There was one more animation. So what's the big news here? It's about activities and devices. Windows is connecting to the Microsoft Graph. That is really the big news here. And we are introducing 2 new entities to the Microsoft Graph, which is devices and activities. And we will be spending a lot of time talking about how these benefit you as developers. The lines that we think about as activities are blurred. We do, as I said, we do common things across all of our devices. As we go through the day, we are interacting with a mesh of devices, a mesh of services. We have a heterogeneous population of devices. Their capabilities are different, right? We have large screen, small screen, no screen. And what devices are you going to find in the Microsoft Graph now? You're obviously going to find your Windows set of devices, your PCs, Xboxes, Windows phones, HoloLenses, and also your Android devices, your users' Android devices, iOS devices. Microsoft Graph gives you that capability of knowing what's in the device graph. Activities. Activities are a unit of engagement. It's not the fact that it's not the music MP3 file, it's the fact you listen to a music file. It's not a document, it's the fact that you worked on a document. Think of it as a verb, doing, did something. So, more Rome pictures. What is Project Rome then? At its very basic level, it's a device runtime that is used to connect and integrate Windows-based experiences and cross-platform experiences. That's built on our infrastructure services. So Project Rome also has a set of infrastructure services to help make this possible. We need some place to store the devices. We have a device service. We have an activity service, right? There are a bunch of services that are behind the scenes that sometimes you interact with directly, sometimes we abstract that away for you. But the last bullet point is really what's most important, what Project Rome gets you. It gets you, we give you these APIs, a programming model delivered as APIs for Windows, Android, iOS, Microsoft Graph, enabling these cross-platform, cross-device experiences. So I think this is a good point for us to talk a little bit about our vision for Project Rome. What we're trying to do is, our vision with Project Rome is to deliver this personal operating system, an operating system that moves with the user where they go. Today's operating systems are tied to a device. There are deep silos between devices. What Project Rome tries to do is break down these barriers. And at our very core, we are a platform that serves you, the developer, and we know that your users are on the move, and we try to help you how to drive user engagement back into your apps. The other important point is Microsoft has had this vision of mobility of experiences. Your experiences should move with you. This is what Project Rome gets you. Rome wasn't built in a day. How many puns can we throw out there? We've been on this journey for a while. It's not something that we just started. Last year, if you attended our talk, I see a couple of familiar faces. We talked about the Windows SDK at that point. We released the updated version of Android SDK in February of this year. And today, as Avalade mentioned in the keynote, we are super excited to announce our iOS SDK and the Microsoft SDK. If you go to aka.ms/Project Rome, all the links are updated. You can go and use them right now. So this is the way that we kind of think about. This is the elevator pitch. What is Project Rome? It's a toolkit enabling you, the developers, to drive up user engagement across apps, devices, and platforms. Oh. So now we're going to talk a little bit about Activity Graph, not too much. Again, please go to the session at 5:30 today. Project Rome Activity Graph enables the experiences that Joe Belfiore talked about this morning. Timeline, Cortana notifications. And I've just got a couple of videos around this. It's essentially the same video you saw this morning. There is, she's looking at a web page. She goes to a timeline. These are rich visuals that you own as a developer using the adaptive cards work. So please go and see Matt Hidinger's session tomorrow. You can provide these wonderful adaptive cards, and these adaptive cards will move with the user as they go. So if the user was on an Android phone, we can just show the card here on a Windows PC, and it'll look just as beautiful. What this helps is this loss of context that happens as you switch devices. And you use the user activity APIs to do this. But this is not just in Windows. In this case, she's using a Surface Studio. She moves to her Surface Book. And Cortana is going to help you to show a notification that the user can effectively get back, pick up where she left off as the user moves between devices. So in this case, substitute your app there, right? What you see on the timeline and in Cortana notifications. Because the other thing that I hope you realize is we are also helping you drive app acquisition as the user switches between devices. This is a very important point because if your app is not installed on those devices, by you participating in these APIs, you can have your app be acquired as the user moves between devices. Not just on Windows. Like we said, we want to break down barriers between devices. This is a iOS device. Cortana is showing the user a mini timeline, for lack of a better word, of the user's activities that she did on her PC, and now as she moves to her Android or iOS phone, she can just pick up where she left off. And what applied on Windows, where we were driving user acquisition, app acquisition on Windows, we will help you drive app acquisition on Android and iOS as well. For your own apps, we'll take the user to the store. Again, we are focused on the user. It's a personal operating system. So please go and see the session this evening. I did not want to cover it here because it's really a large topic, and you need a full hour to go through it. So again, if I haven't plugged it enough, please go and see the session because we think it's important. So let's talk about the device graph. The rest of the session is going to be on the device graph. So what does the device graph let you do? It helps you build experiences that transcend a single device. Going back to slide 2, right, when we showed you the Bill Buxton quote, the quote was, your app has to work well with the ecosystem and an understanding of the user's environment. Is that device available? What capabilities does that device have? Can I access that device? Can I make something happen on that device? And we're going to show you a bunch of demos that show you how you can do that in your apps. So it's not really a Roman quote, but a tale of two devices. How does it work when you really want to have two devices communicate with each other? The first thing you got to do is discover that device, right? I mean, if you want to talk to someone, I'm talking to you, I got to acknowledge you're there, right? So there is a, hello. The first part is device discovery. You got to discover the device that you want to talk to. The second piece is if your app is not already running, we give you APIs to remotely launch your app on the other device. And the third piece is once your app is running, you need to send messages between these two devices. And that's done through remote app services. Carmen?
All right, so let's go ahead and look at some samples. I'm going to switch over to my machine here, which you should see. OK, so I pulled up Visual Studio, and we're going to take a look at discovery. The first thing you want to do when you're looking to discover is you take the remote system object, like you see here, and we're going to call a create watcher. From that point, you subscribe to the events that the remote system object gives you, which is when remote systems are added, removed, and updated. Once you have that in place, we'll start the watcher. In this sample, I'm going to scroll down to see how we handle when remote systems are added. And in this case, it's just simply adding it to this list, like you see here. A part of the remote system, or what we've built into it, is we have the ability to do filtering on them as well. And some of these examples would be if you want to filter by discovery type, authorization kind filter, status type filter, and lastly, on remote system kinds, which, let me scroll down here, which gives you options like desktop, holographic, hub, and so forth. We'll take a look at this in a minute when we run the sample. So once we have this remote system, we need to do something with it. I'm going to switch over to remote launch. And remote launch is really quite simple. Using the remote launcher APIs, we're going to simply call launch URI async, like you see here, pass it in a remote system connection request, and then the remote system that we discovered previously, as well as the URI that we want to launch on that device. Let me go ahead and start this. OK, so first we'll take a look at the filtering that we talked about. So These are some of the options that you have with discovery type. System type, like I mentioned, with remote system kind, you can filter down that way. By status or by authorization. In this case, I'm just going to keep the defaults and hit search.
Demo gods, we call you.
All right,
Yay!
Found something. Okay, so I'm going to do some of my demos from this Carmen Dell machine, which is right next to me. But if I just select it in this tab, it doesn't do much. We need to switch over to the Launch URI tab. From this dropdown, I'm going to select that machine again. And in this case, I'm just going to take the populated Microsoft.com website. I'm going to hit launch, and then Vikas, if you can hit number 1. Oh.
Oh.
Dang it. Sorry. There's the website
Wait,
right there.
I don't believe you. I don't believe
Okay,
you. Do it again.
let me
do
try
it
it
again.
again. All right, I'm going to
You
change
never
it.
know.
Okay, I'm going to launch Bing.com. There you go. Okay, so I found the systems here, and I'm remote launching on this machine.
Thank you.
Now we're going to switch gears. If you could hit 7.
7.
Yep. Now let's take a look at Android Studio and how we do messaging from the Android point of view. So when we come into Android Studio in this sample, and also I want to mention that the 2 samples that I'm showing you right now are available from our GitHub site. So the first thing you do is you come in and you create an app service client connection. You pass it the app service that's running on the remote device that you want to launch or that you want to message with, as well as the app ID, as you're seeing here. Similarly, we're going to use the remote system connection request like we did with launch, and we'll pass it in. And then we need to implement the app service client connection listener, which handles all of our callbacks for when that client connection is established. So let's go ahead. I'm going to go down to where that is. And this is just a private method that implements that interface. We have 3 methods that we need to implement: when the connection is successful, when it's errored out, and when it's closed. Let me get to my, okay. Oh, where's my, sorry. Okay, sorry. Let me just search. Okay, so once we have the connection established, we're going to send our message. And the first thing we need to do is, why is this not? Give me 1 second here. Okay. Sorry, my breakpoints got lost there. Okay, the first thing we need to do is create the message that we want to send. So we've established this connection, and in Java, we're going to use the data construct of a bundle to do this. And in this case, you can see we've created this message, and we're going to add some strings to it. Pretty simple stuff. But on the app service client connection here, we're going to call send message async and pass it that message that we want to send. So the last thing we need to do is handle, once the response from the remote app service, what do we want to do with that? And we do that through the iApp service remote or response listener, which has this response received method on it. And as you can see here, once we do a check that this response is successful, then we choose to do, or then you can do with it what you want. Essentially, you handle the response. And in this case, we get the message and we do something with it. So let me go ahead and run this. Let me first try mirroring my screen here. All right, and I'm going to run it. Okay, So the same device list that you saw before. So I've discovered my devices, and now for this demo, I'm just going to choose from my Android phone, I'm just going to choose this particular laptop, and that's called Carmen F laptop. I'm going to bring it up, and in this section below where you see ping, this is where we handle our app service calls. So when I click connect, it's going to establish the remote or the client connection, and you can see in the logs there, hopefully you can see over here on the phone, that the connection has been opened. I'm going to hit send ping. And now the app service has gone to that remote device on this machine. It's actually this machine. And then, so running it here, and the app service is running on the PC, and it's been successful. So that concludes the loop, and it shows me that the ping was successful by populating this number here. So in a nutshell, I just showed you how you discover devices using the Create Watcher pattern on Windows, and the Launch URI async to use in the remote launcher APIs to launch on a remote device. And lastly, how we do remote app services on Android. Okay, Vikas?
Great. Thank you. I'm on 5. Great. So the way we've implemented these is, remember we started off with the 3 tale of 2 devices. You have to discover the device, you have to launch something on the device, and then you message the device. What we've tried to do here is essentially extend familiar APIs. So everyone should be familiar with Launch URI async, right? It gives, pardon me, it gives the ability for an app to launch something else. So in this case, the parameter is a URI, which is a custom scheme or an HTTP URI. And when that happens, Northwind is launched on the same device. Now, what we've done is we've taken Launch URI async and extended that with the remote systems property. And what that looks like now is you have an additional parameter, which is the remote system, that goes along with the Launch URI async. So it's a very familiar way to do programming. And if you were looking at the Android code as well, the programming model on Android should feel native to you as Android developers, and the APIs should translate pretty cleanly over to Android if you've used, Launch URI async on Windows. Oh, there it launched. Oh, we did the Android already.
Oh,
that's okay.
Sorry.
So if you haven't already familiar with app services, I'm going to do like a 30-second primer on what an app service is. So let's say you have a client app A that's running on device A, and you have another app B that wants to talk to client app A. There are many ways, reasons why you might want to do that. For example, last year we did a talk where Anir and David Bennett presented the whole app-to-app communication talk. If you haven't seen that already, I recommend go and do that. But the use case is that I have a photograph. I'm a photo viewing app, and I don't want to build cropping or filters and all that comes with a photo app. So if a third-party developer can call the Photos app service, which is local to that device, and the Photos app service essentially opens up an app service, which is a background task, and now both the apps on the same device can communicate with each other. That is really the very simple way of looking at it. And what you're doing is you're creating an app service connection, and once the connection is established, you're passing parameters back and forth using value sets. Now, what happens if there's a client app C on device B that wants to communicate with your app A? Same model, right? You're just adding the additional part, which is the remote system that you need as part of discovery. And once you've done that, you're still doing the app service connection, except now it's across devices. You're still passing value sets, except now it's across devices, right? So it should feel pretty native to you as you're using sort of familiar Windows APIs. So stepping back now, we talked about the APIs that are available to you, but what sort of use cases are possible? In the use cases where you want to use all the glass around you, we have a demo that we're going to show you now where that actually becomes very useful. Or you want to use the 2 machines together, like the one on the right, or depending on where you're looking from your side is right, is you have a large screen in front of you where the robot actually is, and you're using a small screen to control that experience. Say that large screen did not have a touch interface, or you want to essentially have a remote control way of doing it. If you want to, for example, you're walking in your house and the song is playing on the Xbox and you don't like that song, you bring your phone up, you skip that song. So what you're doing in this case is you're using your phone as a remote control to the Xbox. You're using all the devices. Now what this accomplishes is this helps you break down barriers between devices. Everything should feel like one glass in front of you. Another scenario is a companion experience, where in this case, the user wants to show something to the other user on her phone, but you don't want to do that, so you send it to the larger screen, which is the companion experience. Another example of that is, say you're playing NFL on the Xbox, and you want to manage your draft and your team from a secondary device, right? So this is where you're building companion experiences for your app. So I think we have a demo now.
Yep.
Oh, sorry, one thing. We are announcing the iOS SDK today. It's published, it's live. If you go to GitHub, it's available.
Okay, so let me give you an example of where this is useful. This is a mirror of my iPhone right now. So using our iOS SDK, I built this Photos app. And as you can see, these are my kids, and I take a lot of pictures of them. I'm constantly going to sporting events, performances, et cetera, and I often run into a problem where when I'm in a group and I have these pictures that I want to share, I have one of two choices. I can either whip out my phone and have everyone huddle around me, which is less than ideal, and you show my pictures, but it works. Or I can essentially pass my phone around the room. But as we all know, there's always that one person who starts thumbing through the rest of your photos, and it's totally uncomfortable. So instead, I built this app to where I can load my photos, and if I press and hold on the screen, look, it's starting to look familiar. This is the device, my devices list from my device graph. In this case, I can scroll through these and choose the PC that I'm running on right here. And once I choose Carmen F Laptop, this app should load any second.
Come on, you can do it.
Remember, the iOS app that we released today is in preview. Let me close this and try it again. All right. All right, let me do something.
Let's just launch the app manually.
All right.
So what should happen is the app would remotely launch on the other device, and she would use her phone to communicate with the device. So as she's flicking photographs on her phone, the second device is the one that's actually getting that connection, and she's using her phone as a remote control, as a companion device to her main device.
Right. Yeah, so unfortunately we have an issue. But so the Photocast app would load, and then I would be able to go through those photos. But I'll try to get it working and see if we can't get that working and come back to it.
All right. All right, so we're back at 5.
Or 5.
But what if? I want to take a moment to recognize this awesome art that we got. This is in the standard template that we get, and I really liked what she was trying to do. I have no idea what she's doing, but it seemed appropriate. But what if you want to make a call from a service or a browser or a web page, or even a browser extension for that matter, or you're a web developer, or you want to make service-to-service calls from the cloud to your devices. So this is where the announcement we made this morning is we are exposing these APIs through the Microsoft Graph. So these REST APIs are accessible to you from any device. You could do it from a browser extension, from a web page. Once you have the user's token, a lot of these scenarios become possible. Carmen?
Okay. So good news. I just want to show you this. Oh, no. No. It launched. And yes. OK, so
Yay.
I'm controlling that. Yay. OK.
Rome was not built in a day.
No. But this is a call to all of you iOS developers out there that we need your feedback and testing. OK, so so I'm going to pull up Postman to show you these Graph APIs that we have, these new Graph endpoints. And in order to get your devices from your device graph, is what I'm trying to say, you just call this simple me/devices. Right now, we're in beta, but when we release later this fall, it will change to V1. So I've already got my access token, so I'm just going to hit send.
Hey.
All right, so if I scroll down here, this theme should be getting pretty familiar. Again, this is the list of my devices. So if I grab the device ID of the Carmen Dell machine that's next to me, and copy that, and then come over to the post request for the launch URI, I can come over here, scroll down, take a look at. So the post request is here, and if I paste the device ID in, like so, it's a matter of putting in the device ID/commands. What's important to note here is that the type of the post is going to be a launch URI, which I'm just going to launch on my screen. And I also just want to show you, just go to bing.com. And because when I hit this, can you hit number 1, please? So I'm going to send that request. And there's Bing. Cool. But what if I wanted to do a custom scheme? So instead, I'm going to number 7, please. Actually, something like make a
002.
Oh, 002. Make a Skype call. Let's see what that does. So I'm going to send this now back to number 1. And look, Skype's launching and asking me, are you sure you want to call Vikas right now? Do you want me to hit it? Or?
Sure.
OK, see what happens.
See what happens. Demo's been good so far. So what will happen here is, oh, that's.
Yep, so I'm calling you.
All right, I guess
OK,
that's fine.
you get the idea.
But the point being that this could be your app, right? The important part is it doesn't matter if you're running on a client, you're running on a service. Project Rome will help you break down these barriers. Is there anything else?
One other thing to note, and I'm not sure I mentioned it earlier, but all of these scenarios are enabled using or on devices running your MSA. So I didn't show app services with the Graph APIs, but we support app services there as well.
Great. So we mentioned this earlier at the beginning of the presentation that we are enriching the Microsoft Graph. Windows is connecting to the Microsoft Graph. We are adding the user's devices to the Microsoft Graph. What this lets you do is it gives you the ability to get the status of a particular device. You can enable commanding to that device. What Carmen just did is she essentially commanded an app onto a device remotely from the cloud, right? So it opens these scenarios up for you that really extends the way you can think about all of the user's devices belong to you, right, for your app. The other important part is this is MSA and AAD support. The bullet point that really matters is we have now given you the ability to turn your app into a service. We all know what a service is, right? A service is something that can be called from anywhere, from another service, from a web page, from an app, whatever. Now your app itself has become a service that you can call upon. There are familiar commanding schemes, familiar messaging schemes that you can use. And the key point is that the URI or the URL is the key programming construct. We call it the currency of commerce. Your URI is essentially the key construct here. So everything we showed you was single user. But we made this claim that we are breaking down barriers between devices as long as they're same device. Not really. Same user. What we can do in the coming update is we can enable multi-user collaboration, multi-user scenarios. So with the remote sessions APIs, you can build apps that enable multiple users in proximity to communicate with each other. So let's say the 4 of us are together. We can have a session where all 4 of us are communicating with each other. We don't have a demo for that. Demo gods were not really good with us getting ready for this, so we put a video. But I can explain as it goes. What you can see here is, and there are 2 screens. From the screen, we are starting a game on the left. And from the screen on the right, you're joining the game. So what's happening behind the scenes is the app is doing a device discovery call to discover other users' devices in proximity. So in this case, the game was discovered. You join the game with your name, and now the 2 of them are in the game together. The one on the left is hosting the game. The one on the right is playing the game. So you can imagine multiple scenarios in this where you can own the party, right? You can create an app where multiple people in proximity are playing these games together, independent of whatever devices that they're on, whatever platforms that they're on. You can build an experience that really brings the party together, right? This is one example that you can do that, but the key thing is that this experience is enabled for devices in proximity. In the future, we'll bring in devices from the cloud, but right now we're just enabling this for devices in proximity. Here's another example that Alex Kipman showed this morning. This is the mod pizza one. So a bit of insider knowledge, when we built these set of APIs, we built this with HoloLens in mind. So when Cirque du Soleil people are on the stage, they are looking at that beautiful thing that they were crafting that I would never be able to do. But they build all that with multiple people in proximity, multiple HoloLens devices, AR, MR, VR, where multiple users are communicating with each other in proximity with a low latency pipe. Right? So you can imagine being able to build these experiences yourself and truly break down barriers between devices. The important part here, again, is it's available only in proximity. And in order for this experience to happen, both the apps need to be in foreground. Right? You don't want users launching stuff onto other users' devices in the background. Right? That's the reason. So the apps have to be in foreground. And once the discovery is made, the session is joined, message passing is enabled between these 2 devices. So what remote sessions lets you do is go beyond a single user. It's through the remote sessions APIs, and you should be able to use it right away. You want to walk through this?
Yeah, so there's really 4 parts to creating a session. The first thing is to use a remote system controller to start a session, like you see in the snippet above. And then you're going to subscribe to the event of when participants join, like you see below.
Oh, sorry.
The next piece is, okay, so you're hosting a session. And like in the game, when you saw when they hit host session, you put in the name of the game and it gets going. And then it's just waiting to be discovered. So participants can now join the session or discover the session. See that it's the same kind of theme, using a create watcher call from the remote system session object. So if you remember back in the remote systems APIs that we talked about earlier, it's the same concepts here. So we have 2 events that we need to subscribe to when sessions are added and removed, or when participants are added and removed, and then we start. Once the session has been established and participants have joined, we're able to create this remote system session message channel where then the messaging takes place back and forth or asynchronously.
Good. So, as we told you, we have SDKs for all the devices out there. For PCs, obviously, the Windows ecosystem, Android, iOS, and now with Microsoft Graph. So these are all available for you to use right now. But isn't everything done by just voice today? You must be wondering what these 2 are here for. So,
Alexa, ask Roam launch our site.
1.
Yeah.
Launching project Roam website.
And there you have it. So that was an Alexa skill using our Microsoft Graph APIs to launch our website.
Next one.
Do you want to
Not to be outdone, we have another speaker here, which is the Invoke speaker, which is actually running Project Roam right now, the Project Roam device runtime. And we're going to launch something on that device.
So what I'm going to do here is now I'm commanding this device to play this song.
So in the first case, what we saw was we used Alexa to launch something on Carmen's PC, which could be, launch your app on the device that is available in front of the user. That was done using the Microsoft Graph APIs. Right? So where in that case, Alexa or Echo was the source, and the target was a Windows device. In the second case, we used an app on the PC to command the Invoke speaker. The Invoke speaker, as I said, is actually running the Project Roam device runtime so that it can receive commands through our infrastructure services, and the communication can happen in proximity or through the cloud. So this kind of shows you the ability to access every device that the user has in the right experience that you want to build. So as a quick recap, our APIs at a base level, we are using the remote launch APIs and the remote service APIs. Remote systems is really the currency of commerce here from a device perspective, because you have to discover the devices around you or through the cloud. And remote sessions enables multi-user collaboration, multi-user experiences. User activity, we did not go into a lot in this session, but today at 5:30, Sean Henry's session, you should go check that out. The other important part is the remote sessions that we are releasing is PC to PC only for now. We're going to bring it to future platforms in the future, to other platforms in the future. And the user activity APIs are Windows, WinRT APIs, and REST APIs that you can use from Android and iOS devices as well. Great. So today we announced the Project Roam SDK for iOS, and also available we have the Windows 10 Insider Preview SDK that you can use. We updated the Android SDK this morning with Bluetooth support and RF-COM transfer for proximity-based scenarios. So you can imagine what sort of experiences you can create. Now an Android device and a PC can work very well together in proximity. Discovery can happen over Bluetooth. And of course, Microsoft Graph. We are connecting to the Microsoft Graph. You saw a couple of demos where we are using the power of Microsoft Graph to discover devices, send commands to those devices, essentially break down the barriers. So, user engagement. I hope you can realize that Project Rome will help drive user engagement across apps, across devices, and across platforms. Call to action, please get our SDK, leverage the device graph and the activity graph. We have a booth down there. Please come and talk to us. We'd be happy to hear from you. And remember, we have the ak.ms/Project Rome. We have a user voice channel. Please talk to us. Let us know, if there are pieces missing in our implementation. If there's something that you need, we'd be happy to. We are listening to it. And of course, #Project Rome. We have GitHub/Project Rome. We have related sessions. One was yesterday, talking about the Microsoft Graph. You should check it out. It really explains Microsoft Graph. Andrew went this morning talking about the app model evolution, how the app model has evolved, to adapt to the new world of device diversity that we are living in today. Later this evening, the user activity talk from Sean at 5:30. And I can't miss the one with adaptive cards that Matt is going to give tomorrow, is it? Yeah. And of course, we are down at the hub. We have Channel 9 videos. We have blog posts coming up. We have a lot of content out there for you to review. Please complete evaluation. Very important to us. And all roads lead to Rome. Any questions? Oh, yeah, please use the mic. Thank you. I'm sorry.
Is it on? Yeah. Right, so when it comes to Windows platforms, obviously you control the operating system and you can get this stuff deeply embedded, but when it comes to iOS and Android, are you basically relying on installing like the Cortana app to provide your conduit, or do you have lower level access?
On Android and iOS, so the question was, let me repeat it. On Windows, obviously, we have control over the operating system. How does it work on Android and iOS? Clearly, we don't have as much control on Android and iOS, but we try to make the experiences work. One is there is no direct dependency on Cortana. I think this is important to state. The other important part is right now, what we are releasing is client functionality on Android and iOS, not the host functionality. So what you saw in all the demos was commanding from an Android and iOS device to a Windows device. Back the other way around is not something that we are releasing right now. It's something that's on our backlog. If you want something sooner, please use user voice. Tell us that you're using it. Give us the scenarios. Talk to us on Twitter or here, right? And we're happy to give you our email addresses. Now, how it's going to work in the future is depending on the amount of capabilities that these platforms provide. I think you can run a background service on an Android device for much longer than you can have on the iOS device, right? So we have ways that we can either use the WNS channel to go to the iOS device to make some action happen, that the user taps on a notification, make something happen, or we can run a background service on an Android device that will receive that message from the host capability to make something happen that you want on the Android device. Hope that's sort of clear. But to be clear, today we have client functionality on Android and iOS and host on Windows, but host on all three is in our roadmap.
Right, so to play the game together, you would start the app on both machines, and then they could communicate.
Exactly.
But you can't launch the app on the other machine.
Correct.
All right, and in your Alexa scenario, who are you as far as authentication goes when you are commanding something? Do you set that up in your skill?
Yep. So this was set up by Cam. What we've done is the identity is the MSA identity. Alexa skill was created using the AWS functions, and communication was done through the Microsoft Graph APIs. That's the way we pretty much put it together. Thank you.
When you're doing the remote launcher, you've got success and failure events coming back.
Yes.
But I have an app that has a custom protocol that launches it now, and you don't get request response, so you don't get a response from the app when it launches or doesn't launch. So have you guys added some magic sauce around that, or is it just you're detecting whether the protocol's been registered on the other machine or whether you can see the other machine?
So let me replay the question to make sure I understand you. Do you have an app right now that's not receiving that command, that ACK back, or are you asking that do we provide that?
I've got an app that can be triggered via a custom protocol. We use a web URL. We integrate our web app with it.
Got it.
I'm looking at using it with this.
Oh, got it.
But our web app doesn't know when it runs the custom protocol whether anything's happened.
Right, so your web app is trying to communicate to something on that device.
So if we use this,
Yes.
this seems to have the success and failure events.
Exactly, it does.
Have you added some magic sauce to make that happen, or is it, I guess I'm just asking, what triggers a failure?
The failure, so yes, we do have magic sauce. But we give you the ACK back of whether the command was successful, what the failures were, even for launching as well as messaging. What triggers it is obviously your command, and you have error codes that you get back to know what happened. We can talk more after this as well, because I think I'm missing a part of your question.
Yeah, it sounds
okay.
like we need to. So.
Yeah, we'll chat. Yes.
So one thing you didn't really talk about a lot was security.
Yep.
How do you prevent malicious use if you've got various machines controlling other ones?
Absolutely. So one, a remote launch is not allowed for multiple users. It's only something that's done for single users. So your phone to your device, so you have to have the token for the user. If you're calling through Microsoft Graph, you need to have the OAuth scopes. You have to register with Microsoft Graph, get your app registered, app ID. In order for the user to give something, the user has to give you the user has to grant permission to your app in order to make something happen.
But once you've granted that permission, is there anything to prevent malicious use going forward? So I could like introduce you to a game, that sounds great, and then once I'm connected, do other things.
We have a sandbox that doesn't let you come out of that, right? So you can launch multiple things on that device, but you're still commanding from your own device. Does that make sense?
But what about in that group scenario?
Right, so the bearer token is what you'll get, and the user, I think you're talking about two different things. One is using the client SDK, and the other is using the MS Graph endpoint, right? So on the MS Graph endpoint, you will have the scopes that you declared that you're going to use, and the user has to grant you that. And the tokens expire in 1 hour. In 1 hour, they expire within an hour, and the user has to grant you that permission, right? On the client SDK, both the devices have to be on. The app has to do something, right? Both the apps have to be on, and the message has to pass between these two apps, which are running in the foreground at that stage. We can talk more about this. Security is one of the top things on our mind. We know with a lot of this power is a lot of responsibility.
One last quick one.
Yeah.
When you're talking about the multi-user scenario,
Yeah.
you kept talking about proximity.
Yeah.
But in the demo this morning with Cirque du Soleil,
Yeah.
one of the guys was from England or something. Like he
Yeah.
hologrammed in.
Yeah.
So that's not proximity.
That's not something that's implemented yet. That's coming in the near future. So what's available right now that you can use right now using our Preview SDK is proximal support only for cloud-assisted sessions. That's coming in the future. It's not something that's available today. Anything else? Yeah.
What protocol do you usually use as a discovery to the other devices, such like iOS and then the Android OSs?
So I think the question is, what devices can you discover?
No.
What protocol?
Yeah, MDNS or some other protocol.
Right, so we have our own, so first you will discover devices around you in proximity, and what proximity means is Bluetooth and LAN/Wi-Fi/TCP. Communication can happen over RFCOM or UDP or TCP. That's sort of below the hood for you as a developer. We don't let you discover iOS and Android devices today because we only have client mode available on Android and iOS. You can discover all of the Windows devices that in proximity or through the cloud.
Okay, so the other, how can I say that, the other iOS and Android device need to connect to the cloud first?
The question is, do the other iOS and Android devices need to connect to the cloud?
Yeah.
Yeah, device registration has to happen to the cloud.
Okay, so after that legislation, so Windows could find that with the discovery services to these devices also.
Correct. So first, the devices have to register to the cloud with that user's MSA. That may happen through your app, or it can happen through Cortana or whatever. But again, Cortana is not a required piece here. Your app can take our SDK and register that user's devices, or do a discovery from that device. We register the device in our device graph once the user's MSA is on that device. And at that point, that device gets in the user's device graph.
Okay.
Does that make sense?
Yes, thank
Okay,
you.
great. I think we have 48 seconds to go. Oh, we have 48 seconds over. We'll be around here. Oh, you have one more question? Can we take a question or two? Nobody's saying no.
You're kind of starting to touch on this. It's not. I mean, this is all based on the MSA, and so I'm just unclear about what the experience is like on iOS and Android. Does the user need to sign in for every app, or is there one that's used throughout the system?
Yeah, so the question is this based on MSA, and does the app need to sign in the user with the MSA on iOS and Android, correct? So first, this is based on MSA and AAD, so both our identities are supported. Second, it's ideal if your app signs in the user with the MSA, but we realize that not everyone uses MSA for sign-in. But if your app is running on Windows, you can use the Windows Account Manager APIs to get the user's token. And at that point, you have the user's token that you can use to communicate between these two devices.
Okay.
Make sense?
Okay.
So the user has to be signed in to the MSA or AAD on the Windows device. So that's where the token can be retrieved from, using the WAM APIs.
And on the iOS and Android device, they would have to sign in inside launch your app and sign in first.
Exactly.
Okay, thank you.
All right. Thanks, everyone.